Alright, today I'm going to discuss why the Wood County Chemical Company should consider switching to fractional distillation instead of using simple distillation. Here, this graph shows the comparisons of the temperatures and the volume with the simple as the blue and the fractional as the yellow. So as you can see, the yellow, it kind of like gradually increases and then at the end it shoots up straight. Whereas at the blue, with the simple, it increases gradually throughout and then steadies off in the end. On this slide, I did a graph comparing the mole fractions with the simple and fractional distillation. So the blue dots is the mole fractions of the simple distillation, and the orange dots is the mole fraction of the fractional distillation. So as you can see, for the simple, increasing the greater than 90% is pretty common through here. So that is okay. And when you do it with the fractional, you can tell it also increases at like the same rate, if not greater. So it has a greater increasing rate, about 112% is what it turns out to be. So when it comes to increasing between 10 and 90%, it's not as normal. They're pretty steady together. It's not a big effect until you get down in this side of the graph. So you're not really able to use it because it's not very accurate. There's not a big difference, so it doesn't really matter. And then when you want to use less than 10%, you're not able to use it because there's really nothing less than 10% unless if you're using simple, and it's just zero. Like there's nothing that's just less than 10%. That's not zero. So you're wanting to use fractional because it's easier, it's more important, and it is easier to with the heat, it's more likely to be helpful.